If you have any question with regards to the topic, please let me know as we go along. So, why do we models? We build models for complex systems because we cannot comprehend any such system in its entirety. We need to develop a common understanding of the problem and the solution that we want to derive at. We need to, or we cannot afford a trial and error approach. We need to communicate the desires, the desired structure and behavior of our system. These are the reasons why. Sorry, one second. These are the reasons why we build models. We build models again because, first of all, sometimes the system is too complex. So you need to build a model if every single facet of the system has been taken into consideration. Sometimes also, the understanding of the system I have and the understanding of the system you have are totally different. Hence, we build a model so that all of us can have a better understanding of the problem. We also build a model so that we can stop a trial and error approach to it. So that it's not like we'll finish building a system and you say you don't like this part or I don't like that part. All of us will have a better understanding of the system we are building. We also build it so that we can communicate the structure and behavior of our system to other people so that they know this is what we want to do and this is how we would want to approach it. We also do this so that we can visualize and control system architecture. We also do this so that we can understand the system we are going to build and expose the opportunities for simplification and reuse. We also do this to do risk management so that we know what are the risks and what we can control, what we can't control, what we should modify, what we can't modify, what areas are strong, which ones are not strong, which ones do we have to buttress more, which ones we don't have to do that. Still under why do we model? The choice of which model we use has a profound influence on how a problem is attacked and how a solution is saved. No single model is sufficient. Every complex system is best approached through a set of independent models. Every model may be expressed as a different level for fidelity. The best models are connected to reality. Again, sometimes you would come to do that. And for example, when you're doing your final year project work, you realize that someone will come there with their documentation and then the system they are developing has one flow chart, one context flow diagram, one use case diagram. It is a system. There are different views of the system. So your diagrams have to have all these views into consideration. So the model I choose has a profound effect on how I want to portray the system and what I want to convey, the message I want to convey. And in truth, no one system conveys everything because a particular system conveys how data is flown through the system. Another module controls how activities are performed. Another one looks at interaction. Another one looks at how various components communicate with each other. So if I'm building a system, I will pick models which will help me convey a message to the people who are going to use the system and then are going to have access to it, or the stakeholders. So every system may be expressed as a different levels for fidelity, and the best models are always connected to reality. That is that if I build a model for a particular system and I come to you and I tell you any scenario that happens in the day-to-day of us at the organization, and your system cannot accommodate that day-to-day operation we have in your system, then it doesn't match my reality. If we take you guys, for example, you guys do registration. The registration is a process. What process is it? It starts from paying at the bank. Once you pay at the bank, your account is activated by the accounts department. You register your courses, you print it out, you send it to the department. They have a copy of your registration, and so on and so forth. Now, if you do not do any of these things, it's a big problem to the university because the rules or the procedure or the business processes are outlined perfectly. Your job, therefore, is to follow these outlines, right? So if I am building a system for registration and it doesn't follow the outline, doesn't follow how the normal flow of the business would be, one, the business adapting it will be very, very hard. Two, it doesn't match how the system works on the ground. Hence, your model will not work for us. Let's keep that in mind. Now, why are we talking about modeling and why are we talking about design and so on and so forth? Because we are going to know what a data model is. We are going to learn the concept of entities and relationships. We are going to learn how to draw an ER diagram. We are going to learn how or what are keys, what are weak entities, and what is an extended ER model. We are going to learn all of these things. So what is a data model? For representation of a part of a real world. So that's what data models are used for. We use data models to represent a part of a real world. Please, I want you guys to understand something at this point in time. That when you are building a database, you are building it based on certain criteria from a particular perspective. That word there is very, very key. So before you start building the system, before you start putting the system together, you need to understand what that perspective is. You need to know the system in which I am building, what perspective am I focusing on? It's very important we understand this, that if you take the school, for example, the school or the university has a lot of moving parts. You have the departments, the faculties, the IT, the accounts, the HR, the legal, the management, all of these portions have roles they play and things they do. If I was building a system, hi, can you hear me?
Yes, sir. It's okay now.
Okay. So, as I was saying, if I was building a system for the school, very important, for the school, I will have to decide which part of the school I'm focusing on. You can't build a model for everything at once. And I want you to keep this in mind as I'm saying it. At the end of the day, you will build for everything, but you need to focus on a particular aspect and build from there. And that would be easy for you to design the databases in which you want. I want you to keep that in mind. Now, it is an abstract of the reality. That is, there is the real world and there is what I'm designing. So what I am designing it with the notion that anything which is unnecessary, I am leaving it out of my world. So I am creating my own world, focusing only on the tasks which will help me achieve the aim in which I am building the database for. So before I build a database, before I build a model, I need to know what aim I have for it. Then when I start building it, anything which is not relevant to my aim, I'll remove it. So back to the registration thing. In the registration line, who are the most important people in that line? We have the department because they need to interact with you with registering of the courses. We have the accounts because they need to manage how much money you pay and verify if you've paid. We have the IT because they have to provide support to you. In this picture, any other department is out. Management plays no role there. So in the university, there is management. But in the line of the business processing, which I'm talking about, management does not come in there. Am I clear?
Yes, sir.
Represents operational data and real-world events, entities, and activities. Models may be at various levels depending on requirements that are either logical or physical, or external, conceptual, and internal. So, with that in mind, a good model is easy to understand. That means the models you are about to draw, when you are done drawing them, they should be able to convey a particular aim as easy as possible. There are a few concepts, and it permits top-down specifications. Models offer concepts, constructs, and operations, and they must capture the meaning of the data, not just the data. For example, if I take you as a student, right, and I provide you with your data, so let's say your index number, for example, the moment you mention your index number to me, I have a perfect understanding of the index number and when you came to school, what level you are in, when you should finish, what grade you started on, and so on and so forth, just by you mentioning your index number. So when I am capturing data from you, it's not just about the data I'm capturing. It means that when I capture the data itself should provide meaning to me. And that is the semantics part. So to an outsider, you mention your index number as 42 or 42311 or 41111 or all of those things. To them, it may not make sense. But to me, the pattern shows me or gives me a lot of meaning or understanding to who you are, when you started school, when you are supposed to finish, and so on and so forth. So once the data is not just a matter of collection, but also has meaning, then we can do interpretations and we can manipulate the data very well. Now, the semantics or us capturing meaning from the data is gotten through the following. And again, let's take note of these things: data types, interrelationships, and data integrity constraints. Again, they are data types, interrelationships, and finally, data integrity constraints. Now, this will ensure uniqueness, existence dependency, and restrictions on some operations such as insertion and deletion. So we will look at this, especially when we start working with databases and we start designing the database physically. We will see these in operation. So again, the models you design, make sure these things are there. And we'll explain these things as we go along. So, not to waste your time, what is an ER model? Now, the ER model represents entity relation model or entity relationship model. So what is an ER model? First of all, it is used to represent the real world. It represents the overall logical structure of information in terms of grouping of data elements and interrelationships between the groups. With that in mind, we must discuss what is an entity. An object that exists is an entity. It is different or has a distinction from other objects. It could be concrete or it could be abstract. Let's pause there. An object that exists. Let's start from there. In the environment called the university that you all belong to, tell me some objects that exist. Or let me rephrase. Tell me some elements that exist in the university that when you enter into a university or you enter into your university, you should be able to see. Peter.
One, I can see buildings.
Okay, so you can see buildings. Daniel.
Yeah, faculty.
The faculty. Can you see the faculty? Daniel.
No, sir.
Oh, I'm asking, can you see the faculty?
No, sir.
So is the faculty an element that exists in the university?
No, please.
Daniel, are you sure? What faculty do you belong to?
Faculty of Engineering.
So does the faculty exist in the university?
Yes, it exists.
Okay. So Daniel, you see this third point here that says that the entity could be concrete, that it could be something physical you see, or it could be abstract, that is something you do not see, but we give meaning to it, we give life to it. For example, if I came to you guys and told you that the Faculty of Engineering, the students there, they don't know anything, then shut off. Daniel, you know go ball.
I go Boza.
Why you go ball? Have they written on your forehead that you are Mr. Engineering?
No.
But you believe in it. You have an identity of it. Do you understand? So the
Yes.
things we mention, they can be concrete or abstract. So the answer of if the faculty can be seen, no, it can't be seen. But does it exist? Yes, it exists. How do you know it exists? Because you even belong to one. So I was trying to trick you. And again, that is how your examination is going to be. I will trick you on things to see if you have a correct understanding of it. There'll be no what is this and what is that and only your questions like that. But all your questions are going to be to test you to make sure you are certain and you are confident in your answers. So Jacob, tell me another thing that exists in the university environment.
We say the cafeteria.
Now, before we go into that, let us all agree that we are grouping the items into one. So the cafeteria is a building, so all of them are buildings. Are we okay?
Yeah.
So give me another one.
A car park.
Let's put all of them under the buildings. So facilities and buildings, they are all one. So give me something else. whilst you think, it is very important that from this day onwards, as an IT software system person, whenever you enter a place, your eyes should see the various entities that are there, the various groupings that are there. If I was the one listing the things I would find in a university, I would see courses, I would see students, I would see lecturers, I would see departments, I would see faculties, I would see buildings and facilities, I would see administrative employees. Now, if I was building this environment from a different perspective, and the perspective was for student registration, then I would see students, I would see departments, I would see faculties, I would see the accounts, I would see payments. If I was seeing this from the perspective of me dealing with results and results management, I will see students, I will see lecturers, I will see courses, I will see academic years, I will see the students' classification, that is morning, afternoon, evening. So again, the world exists, but that object must exist in the world you are defining. And it is very important that whenever you have a world defined for you, you should be able to identify the things which play a role in that world. And those are the entities. And again, they must be distinguishable from other objects. So I can't say, for example, as we did, car park, block A, block B, block C, faculty engineering building. All of those things can be grouped as one. That is why I say students, and I don't mention your individual names, because entities are groupings. They're not individuals. Is that clear?
Yes, sir.
So on the screen here, when they are given examples of entities, they say a book, an item, a student, a purchase order. So things in which can be grouped that form an environment is what we call entities. And again, from this point onwards, you should be able to identify players in an environment. So what is an entity set then? And again, here it comes to English. Technically, and again, I want to make sure we understand this very well. When I say entity, I'm talking about one item. When I say entity set, then I'm talking about the grouping. I know what I said previously, but the word entity has been used so much that now when we say entity, we are actually referring to entity set. But technically, entity is one item from the group. So if I have an entity set of students, you, Daniel, with your index number, is an entity of the entity set students. But again, we have used the word entity and entity set interchangeably so much so that they have married together that whenever someone says entity, they are referring to entity set, but technically in English, it is wrong. When he says student, book, car, faculty, the things we listed earlier, we were referring to the entity set, not the entity. The entity is one person who belongs to the set. So for example, here, a set of similar entities need not to be disjointed from an other entity sets. For example, supplier and customer may have common entities. A set of all books in the library, a set of all customers. Entity set also called entity type or entity class. Entity considered as an occurrence of an entity type, that is an entity set. So when I have one of you, then I'm talking about an entity. So in a library of books, if I have one book, then it is an entity. But again, the word has been used interchangeably, so much so that whenever we say entity set, we are referring to what? The entity. Is that clear?
Yes, sir.
Please, if there's something you don't understand again, let me know, because we are building up to something. Now, what is an attribute? If I have a particular entity, and remember, the entity describes a group, very importantly. So if I have a particular entity which is describing the group, every member of that group should have characteristics that make it a member of the group. If a member of that group does not have even one of the characteristics, then he's not a member. So he should be taken out. So the attribute is, or an entity has a set of attributes. An attribute defines the property of an entity. That is, if I have an entity student, what are the characteristics that makes you a student in my environment? And again, I'm using the term very carefully, in my environment, because the term student could refer to a class 1 student, a JSS student, a SSA student, a university student, a student for art class, a student for a gym. What type of student are you talking about? Because each person in that environment, there are different pieces of information you will take for that student. So you must define the environment. And the environment will allow you to understand the information and attributes that make up the student. For example, if you want to be a student in our school, Mr. Bright, what characteristics do you have to be a student in our university? Mr. Bright.
No, sir.
We are waiting on you.
No, sir, please, have it through my next step.
We can't hear Mr. Bright, so we'll give him -5 and continue. Mr. Jacob.
Yes, sir.
Yes. So what kind of characteristics do you have to have?
I think the person needs to have a good sight that's not blind. Or
Mr. Jacob, pause there. That, what term would you give such a thing? Or let me rephrase, if you are blind, it means you can't attend the university.
not our university.
Are you sure? We are a public university, which means technically if you are blind, you should be able to attend. Blind people do not come though, but if they came, the school was supposed to make accommodation for them by law.
Okay.
But that said, what word do you define there? By law, when you were coming to the school, what question did they ask you when you were filling that portion?
If you have, I think they said if you have a special
Starts with a D.
disability, yeah.
Good. So they don't say if you are blind, don't come. So they don't list them. They said, do you have a
Disability.
good? What else do you have to have before you can come to the school? But before I ask, Mr. Jacob, are you a student?
Yes, I am.
What makes you a student? Do you have a name?
I have a name, yes.
Are you sure?
Yes,
Okay. Do you have an index number?
yes, I have.
Are you sure?
Yes, I have.
Do you belong to a department?
Yes, I do.
Are you sure?
Yes, I do.
Okay. Do you belong to a faculty?
Yes, engineering faculty.
Okay. Do you have a phone number?
Yes, I do.
You have a nationality?
Yes, I do.
You have a gender?
Yes, I do. Wow, yeah.
Oh, you have a gender. Okay. You have an email?
Yes, I do.
Oh, when you're filling the school, I think you filled guardian, right?
Garden, yeah.
Oh, so
Not
you have a
yes,
guardian.
yeah.
Oh, okay. So that's your emergency contact. You have an address?
Yes, I do.
Oh, okay. So let me ask the question again. If you are to be a student in our university, what information do you have to have?
Please come again. What information?
What information do you have to be a student in our university?
So you need your name,
Mhm.
both first name and surname.
But people don't have
Address.
other name.
Yeah, and middle name. Okay. Address,
Mhm.
name, address, email address, contact
Mhm.
number.
Mhm.
Yeah, garden and all that.
Don't you think that the
You understand?
ID at department and faculty are very much more important?
Yes, but okay. Before admission, okay, you fill this before admission,
Okay.
and when you get
Okay,
admitted,
wait. Let me ask you this question. If you were a student in our university and you had a
okay,
name, address,
index number.
guardian, and all of those things, right?
Yes, sir.
And you didn't have an index number, are you a student?
No, you are not.
So it's a requirement for you to be a student.
Okay.
Do you understand what I'm trying to say? The things you are mentioning, if you don't have one of them, you do not exist.
Yeah.
So for you to exist as a student, and this is where our mentality has to change in terms of the things we are looking for. We are looking at people who play a role. And when I say people, courses, or let me not use the word people, but things that play a role in creating the university, physical or non-physical. So if
Yeah.
I say you are a student and you play a role in the university, then your attribute are the things that make you up. So much so that if one of those things you don't have, you are not a student. Do you understand what I'm saying?
Yes, sir.
Let's go to Mr. Peter. Mr. Peter, for you to be,
Yes, sir.
for you to be a department in our university, what do you need to have?
Please, sir.
For you to be a department in our university, what do you need to have?
First of all, I have to let them to know my nationality, my
Pause there.
that
Pause there. I didn't say for you to be a student. Oh. I said, if you are a department in the university, what do you need to have?
Please, I can't get.
Do you belong to a particular department?
Yes, sir.
How do you know you belong to a particular department?
Because of the course structure. The course structure.
So the course
that I'm
structure
doing-
makes you know you belong to a particular department.
Yes.
Okay.
Yes,
What is the name of your department?
Engineering, Faculty of Engineering.
Okay. So if you are a department in the school and you don't have a name, will you be a department?
No, sir. No, sir.
So what do you need to be a department?
Name.
Name. What degree do you offer? Students of the Department of Computer Engineering, what degree do they get?
Bachelor of Computer Engineering.
So
Bachelor.
you need to offer a degree.
Yes, sir.
What is the code of your department? BCE.
Yes, sir.
So before you become a department, you must have a code. Again, these things here come with time, especially because of the way we have learned things. But when you are looking at someone, you should see the things that make them up. And it is very important that each of them should have a value. So for example, if I say classification, if I go back to students and I say every student will have a classification, that is, they are either going to be a morning student, an evening student, or a weekend student. The value may change over time. This point here means that a particular student can get a job and say, okay, I don't want to go to school in the morning sessions anymore. I want to be an evening student so that I can work and come to school. This thing here, that the value may change. It works because the attribute is classification, but the value is morning or evening or weekend. So the attributes are defined for entities in a set. For example, if I have a book, what do you have to have for me to call you a book? You must have a title. You must have an ACC number. You must have a publisher. You must have a price. You must have an ISBN number. You must have an author. You must have a year that you were created. So if you have answers for all of these, that's this book here is Harry Potter. Its account number is 2221. Was published by so and so. He has a price of 2,000. The ISBN number is 444555. The author J.K. Rowling. The year 2010 or whatever. The moment you have those values, then we have created a book. But all of these things here define what you should be so that we will call you a book. Do you understand?
Yes, sir. Yes, sir.
Are you people sure? Because the answers you give me, they are not sure. Now, the attributes may have multi-value, maybe multi-value. That is, a book may have multiple what? Authors. An attribute which uniquely identifies the entities of the entity set is called the primary key. Again, this term is the terms we are going to be are going to start coming up very soon. Third term, primary key. What is the primary key? It is the attribute that uniquely identifies individuals in the set. So for you guys here, the index number is your unique identifier. In this school, there could be 100 Victors, 100 of them. But the moment I mention the index number of Victor, the one in my class, he will stand up. Why will he stand up? Because that is uniquely identifying him from all other attributes. So with the help of Excel, I can say that if I have an entity called student, so this is my entity, it's called student, right? What are the various attributes that would make someone a student? You would have to have a name, a DOB. I hope you all know what DOB is.
Yes.
Yes.
He will have to have an index number. He or she will have to have a phone number, an address, a classification, a department, a court. I hope you all know what court means.
No, sir.
Uba school year, Ben.
Oh, just recently I started this year.
That is what the court means.
Oh, okay, okay.
So, for example, if I was filling this form here, I would say the index number of the student is 0001. The name of the student is, let's say, John Corner. His DOB is, let's say, that. His phone number is, let's say, that. His address is this. His classification is evening. His department is, let's say, BCE. And he belongs to the cohort of 2023/2024. So this is when you started school. So these are the things that will make you a student. This here, the word student here is your entity. That is, all of them are defined under this. This thing here are your attributes that make you a student. Now, the things we have over here for each of them, right? So for this one here, and then for this one, and then for this one, is the value for the attribute. So each attribute will have a value. So for index number, the value is 0001. For name, the value is John Carner. For DOB, the value is the date. For phone number, the value is there, so on and so forth. Now, the attribute here, which will uniquely identify you, is what we are calling the primary key. So in this diagram we have in Excel, the primary key that I've made in red is the index number. Why? Because John Connor, another student, could be called John Connor. But if he has an index number of 00002, then he is different. A good example of this is this. Last year, we had a student who was called Lamte Mills. We had 2 students being called Lamte Mills. And what happened was that because they were called Lamte Mills, they all were given the same index number, which was a mistake because they thought they were the same person. So they went to one person in the department. My name is Lamte Mills. This is your index number. Went to another person. My name is Lamte Mills. This is the index number. So they gave them the same index number with the students not looking at their letter to see that they had different index numbers. So one person would log into their SIP, go and register their courses. When the other person comes, he sees that the courses are registered, go and reset the password. The other person comes, resets the password again, and it is back and forth until the middle of the semester that both of them now realize that, hey, we are in the same mistake. So the only thing which will allow us to show that you are different from this is the primary key, because all of them will have values. But if the values for all of this is the same, the only difference would be the index number, because the index number must be unique and must be distinct. Now, we are saying also over here that a composite attribute is, for example, is a date and an address. Why is a date a composite attribute? It's a composite attribute because it consists of a lot of other things. There is day, month, and year. So you don't have only one value there, but you have a group of values coming together to give you that thing's value. If you have an address, the address, you have the street, the postal code, all of those things coming together to form the address. So they are different. Hence, if you have an attribute that has a lot of things coming together to give you one value, then it is a composite attribute. Are we clear? What is a domain? A domain tells you in what circumstances the value of the attribute is permitted. The domain tells you in what environment is the values for the attribute permitted. All values may not be present at all times in a database. How true is this? For example, if you have a database that you have columns or you have attributes for first name, surname, middle name, and you have Joel. Joel, do you have a middle name?
Yes, please.
Oh, and a bad example. Who here doesn't have a middle name? We all have middle names. Okay. So let's say we had a scenario whereby we had a student who did not have a middle name. Okay. So he enters the first name. He enters the second name. That's the surname. Now he has to enter the middle name he has. And he doesn't have one. Should the system stop for him? Should we force him to go and get a middle name? how will that situation work? So, in truth, not all the attribute values will have a value at the time you are creating it. There are some attributes in which you cannot leave empty at the time you are creating it, like the index. So let me rephrase, like the primary key. The primary key cannot be left empty because it's supposed to be a unique identifier. So if you leave it empty for one person and leave it empty for another person, now you have two things which are empty and identical. Hence, it's not a primary anymore. But there are situations whereby some attributes will be left empty. Now, the domain allows us to know for that value, what are the things in which is permitted for you to enter there. So for example, if I am taking the age of somebody, I do not want the person to type, if the person is 20, the letter form of 20. I want him to type only numbers. So I will force the computer to acknowledge that the entry of that field is going to be only what? Integers. So it means that the domain or the possible values that can be given to that attribute should only be what? Integers. There are times whereby the domain is not just going to be a string, but a set of letters. For example, if I'm talking about you people and I'm talking about classification, then the only classifications I can have and are acceptable is morning, evening, and weekend. If you go and type daily, hourly, or any of those things, it shouldn't work for you. It shouldn't allow you to type any of those things because the only thing there that is acceptable is morning, evening, and weekend. Is that clear?
Yes, sir. Hello, sir.
Yes.
And when you are talking about the primary key, can we consider email address as a primary key?
We can consider email address as the primary key.
Oh, okay.
So over here, we have an example of a college, right? And we are saying that we have student courses, teachers, and departments. Okay. Who can tell me the student courses, teachers, and departments, what are they?
Please, they are entities.
Entity.
Very good. And then the ones on the right-hand side, what are they?
Attributes.
Very good. So for you to be a student, they are saying that what kind of attributes do you need to have? Per their college. Who can tell me?
Please, sir, come again.
For you to be a student, an entity student in their university college, for the example here, what are the attributes you need to have?
You need to have a roll number,
Uh-huh,
a name,
uh-huh,
a hostel number, and a date
Uh-huh.
of birth.
very good. That means that you see that here, they don't care about anything else. So far as you have these things here, then you are a what? A student. The cost to what do you need to have? You can speak at random. Or I should be mentioning names. Okay, let me mention name.
Host number,
Mhm.
name, and credits.
Good. Now note that the environment can change. Please note that. For example, if I tell you that what are the attributes of a student who is in JSS? No, let me not say JSS. Who is in primary school? What will you say? List 10. What will you say? Yeah. Who can list 10?
We
Daniel.
have name,
Uh-huh.
date of birth,
Mm-hmm.
parent's name.
Before you go out, Jacob, always start with the primary key.
Okay, so there'll be surname.
The surname cannot be the primary key. How many Mensons do you know? How many Mensons do you know? Is Jacob there?
Yes, sir.
How many Mensons do you know?
A lot of them.
So you can't use Mensa surname as your primary key. Do you understand? Because it is not unique.
Okay, sir.
So what will you use as the primary key for the student in the primary school?
Uh, date of birth.
Have you never celebrated your birthday with somebody before?
Yes, I do.
So
Hello.
can we use date of birth as the primary key?
No.
Do you understand? The
Yes,
moment
sir.
that value is not unique, we can't use it as the primary key. So we can say student ID
Okay.
so that we can list the students from 1 to whatever they are.
Yes, sir.
So in a JSS, in a primary school, what information will you take for the person to be a student?
You have the name,
Uh-huh.
date of birth,
Uh-huh.
class,
Mm-hmm. When you are in
Father's
primary,
parent's name.
very good. Because when you're in primary school, when there is a problem, they don't talk to you. Who do they talk to?
your parents.
Your parents. Again, we are starting the course, but very soon, I would want you people to create these things fast. So we need to hone our ability to identify individuals and the characteristics that make them up.
Yes, sir.
Now, in the example, we would refine further to say the following, that the perception of reality and focus of design would have indication of more entities, that is hostel and semester, or could only be an attribute. Okay, so an exercise. Let us all design the entities or mention the entities that would make up a hospital.
We have the word, the specific words,
The wards, okay. What else?
OP.
The net. Okay.
Then OOP. No OP, any ward, be. It's not just one person, no. It's all of us. Okay, let me
The
go back
staff-
to just
the staff-
mentioning names.
Staff, nurses, doctors.
So are you grouping them all under nurses, doctors, or what?
No, I think there should be a distinction between because at the hospital we should have specialists, probably maybe cardiologists, dentists, and all this.
Okay, so let's refine it. Okay, the question
Yes,
I
sir.
asked was this: are you going to put all staff under one umbrella, or you break them down to doctors, assistants, nurses? What are you going to do with that?
I
Okay.
think we have to break them down.
Do you want to break them down?
Yes, sir. Based on their functions.
Okay, so let's start again. To you, what are the entities in a hospital?
So we will have the medical staff, the wards.
Let's see if someone else too can say something. Daniel, if you were given a contract to design the database and look at the entity relations in a hospital, what would you say? Mr. Daniel.
Okay, please, sorry, I'm on my way to work, so there will be a noise. The departments, administration and department, and you have the nurses, staff ID.
So you have department, nurses, and staff ID.
Yes.
Is that what you said?
For the entity, you have department.
One.
You have staff.
Two. Have you people been to a hospital before we go on?
Yes, sir.
If you have not gone to the hospital before.
Yes, sir. You've gone to hospital before.
Okay. When you go to the hospital, what are the things you see there?
So you see evening, you see nurses, folders,
You see
equipment.
folders. Okay, equipment. Okay.
Yeah, equipment, folders, the personnel's. Yeah, and other things, the building, everything.
Now, using what you have learned today, whereby we are saying that when we say entities, we are talking about a group of things. The group could be concrete, physical, or non-physical. If you were to build a system whereby you will list the entities of a hospital, what would you say? Now, People have said wards. So we have put in wards is okay. People are saying medical staff and then medical assistants. So from this point onwards, we will not say nurses and all of those things anymore. We have grouped them into medical staff, medical assistants, and administrative staff. So now we have three categories for the workers. So we have wards, medical staff, medical assistants, administrative workers. Those are out. What again do you see in the hospital?
Please, what about medical equipment?
So the equipment, one group. Okay, what else?
The drugs, the medicine
So the
itself.
pharmacy. The pharmacy. Again, we don't say the individual drugs, because if you go that route, then you say the drugs, the bandages, the cotton wool, all of those things. One word, pharmacy. They are supposed to be a group. I hope we understand that point.
Yes, sir. Very clear.
Okay, so pharmacy. What else?
Hospital equipment like beds.
We have stated that in already. We mentioned equipment and we put all of them under one thing. Are we okay? So what else?
Utilities like water and then light.
Hi, is Mr. Hansen here?
We will see patients. The people, sick people.
Patience. Very good. Patience. Is Mr. Hansen here?
I said my network is funny, so I used to.
Because I just saw in the group that you're saying it is not connecting or something. So, okay, no problem. So, patience. Again, when we are just starting the course, so it is difficult to identify groupings. But when we go further, you being able to identify groupings are very important. Right? I hope that is very, very clear. Now let's talk about relationships. We're not talking about the male-female relationship, not that one. But the entities in which you mentioned, there should be a relationship between them. There should be a relationship between them. What do I mean? If I take the school environment and I take you guys, there is a relationship between you and I. What is the relationship? I teach you. But I teach you via the course. So you will enroll on the course. I will teach the course. Hence, I am teaching you people. So that is the relationship we have. Relationships association among entities. A particular book is a text for a particular course. That is, the students will enroll on a particular course, and the course will have a textbook they are supposed to go and buy from the bookshop. Let us look at entity sets, and I think the next slides would start to allow us to focus on everything and bring everything together. An entity set is a set of relationships of the same type. So the word relationship and relationship set are often used interchangeably. Between certain entities sets, we have a binary relationship, that is between two sets, and then we have a ternary relationship among many sets. An example of a binary relationship. Students study a course. That is a binary relationship. And an example of a ternary relationship. Students, course, and teacher. And that's the example I gave you, whereby there's a relationship between the students, the courses, and the teacher. The students enroll on the course, the teacher teaches the course, the students are taught by the lecturer, so on and so forth. That is the relationship among them. So if we are looking at this diagram here, right, we can see that here we have an entity set called student. In here, we have the various students. Are we okay? Here, we have an entity set called course. And over here, we have the various courses. Now, the relationship is that this student here takes this course, and this student here takes that course. He does not take any other courses. So there is a relationship between them so that one student can take many courses. And many courses can be taken by a single student at a time. Before I go on, do we understand the relationship part? Should I go to relationship cardinality?
Please, can you explain it further?
Okay. One second. I'm coming, yeah? I'll be with you in 1 second.
All right,
No
sir.
problem.
Okay. I am trying to fetch two things that will help me explain to you the relationship very well. I've gotten them, so I'm coming to show you them to you. Let me put them in the slide so that it would be easy for you guys to see. Wonderful. Okay. Wonderful. All right. Now let's see if we can discuss this. So I'm coming to share the screen back. Here we have the screen back. Wonderful. So now let's look at this again from this perspective. Yeah. Over here, I have this diagram here. Now, this here is the entity relational diagram. This is what we are building towards. But before I discuss this diagram, over here, I have a student. This is a student. This is a course. The student has the following attributes: name, student number, email. The course has the following attributes: title, course ID, duration, what you will call your credits. The student joins a particular course. When you people start your semester, there is something you do called registration. A lot of you take the registration lightly. A lot of you would register very, very late, and some do not even register at all. What does registration mean? Registration means that you are telling the school that you are taking a particular course for a particular semester. So the student joining the course here on the surface looks very, very simple, but it's not. Because this student can only take one course from here. If we come to a more complex situation where we have a book, we are looking at a scenario like this, whereby a book can be published by a publisher. A member can read a book. So in this relationship we are looking here, a book can be taken or borrowed by a particular member, and a publisher will publish a particular book. So the publisher can publish many books, and many books can be published by a publisher. Members can go to the library and borrow many books, and many books can be taken by a particular member. So if I ask you, what is the relationship between a book and a member? A member can borrow a book. What is the relationship between a book and a publisher? The book is published by the publisher. So that is their relationship. Do we understand? Do we understand?
Yes, sir.
That
Hello,
is,
sir.
yes.
If I understand this, what it means is it like a relationship between two sets or two objects? Is it like that, sir?
The relationship between two entities.
Yes, sir.
That is what we are talking about. Now, in the modern sense of a database, your entities must all have relationships. Or your entities must all have a particular relationship between another entity in its environment. Is that clear? What is the cardinality of an entity? It is a constraint on a relationship. It categorizes relationships further, giving us mapping cardinality. How many entities of a particular set participate in a relationship? It's especially useful for binary relationships. That is, here we are looking at one-to-one, one-to-many, many-to-one, many-to-many. What does this mean? What does this mean? And let's come here. The relationship between a student and a course is that one student can take many courses here. So, and a course is taken by a particular student. So you can take the course we are doing now. So it's a one-to-one relationship between me and you. You can also take another course, mathematics. So this student here can take a course, mathematics. This student here can go and take another course. This student here can go and take another thing. So the relationship between this and that is one to what? Many. And that is what we have over here. One to many. One entity in A may be associated with 0 or more numbers in B. But the correct definition for this diagram here is not one to many, because many students here are taking many courses over here. So the relationship here is more many to many, where one student in A may be associated with many students in B and vice versa. So that is the relationship cardinality we have here. So many students can enroll on many courses, and many courses are being taken by many students. So that is the relationship they have. So it is not just the student joins this. That shows you the relationship. But the cardinality shows you the directional flow of the relationship. Is it one person here taking many things here, or one person here taking many things here, or many people here taking many things here, or it is just a one-to-one relationship between them? That is the cardinality. So if we have an example here, we can see that teachers from the teacher to course is many to one. It is one to many. That is, I, as the teacher, can teach many courses. For the relationship between the student and the course, it is many to many, because you, the student, can take many courses, and the courses can be taken by many students too. So it is a many to many relationship. But me, the teacher, me, one teacher, I can teach only one course. Then after that, me, that same teacher, will go and take another course. So if the relationship is one to what? Many. For example, this semester, I'm teaching 2 courses. So I have a one, that is me alone, is taking two courses. So it is one to many. But you, as the student, you are taking many courses. And again, that course is being taken by many students. So as I said earlier, the relationship there is many to many. Do we all understand?
Please, why is it many to many? Because a course is taken by many students. So I think a course is a course on its own, like one, and the students are many. What about that? I thought it's going to be many, one to many.
Okay, so in the one to many, let's look at that again, right? They're saying that if you have one to many, if you have one to, where is it? If you have one to many, they are stating that, let me get the pointer. One entity in A may be associated with 0 or more numbers in B. So again, if this here, okay, if here, let's say here was lecturer, are we okay? That means this thing here, this side here is A, this side here is B. That means one person here in A is associated to many people here in B. Okay? Now let's use the example of the student. Can one student take many courses? I just want a yes or no answer.
Yes. Yes.
Very good. So that it's this looks like one to what? Many, right? But remember, there is also the other direction. In the other direction too, we are looking at it so that there is also one to many in that direction too. So let's look at this again. Over here, right? Before we ask the question again, here it is the students. It's not just one student. So here, if I'm looking at this from my point of view, all of you in this class right now, you are 8. Each of you is a student. Are you many or you are one?
So we are many.
Good. Are you all taking the same course?
Yes, sir.
Yes, sir.
Are you taking
Yeah,
other
like,
courses?
Yes, sir.
So here it is many to what?
Many to many.
Good. Are there lots of courses in which are in the engineering level 300 class?
Yes, sir.
Are they being taken by many students?
Yes, sir.
So in the vice versa to it is many to what? Many.
Many.
Let's take it from the lecturer's point of view. Is the lecturer teaching a particular course?
Yes, sir.
Is the course being taught by 2 or more lecturers?
No, sir.
So it is a one-to-many relationship because the vice versa also doesn't work. Because here we don't have a situation whereby many courses are being taken by many lecturers. Only one lecturer can take many courses, but the opposite does not work. In this scenario where we have the student, we can have the student situation whereby one student can enroll on your course or 3 students can enroll on your course. That means you have many students enrolling on the course. And we can have the vice versa whereby the course is being taken by 1 student or the course is being taken by many students. Hence, you have many to what? Many. Do we understand?
yeah,
Hello, sir.
yes, sir.
Hello, sir.
Yes.
Please, I will need some explanation. Does it mean that one to many can never be many to one?
Does it mean that one to many cannot be many to one? It can
Yes,
be
sir.
many to one.
Because from the scenario, let's assume the lecturer becomes an entity and he has about 8 students. So that becomes one to many.
Yes.
And let's put our shoes in that of the students, being many. Now the student is assigned to many lecturers.
Also, are you talking about the relationship between the lecturer and the student, right?
And the student, yes, sir. Yes,
Okay. So the lecturer-student relationship is many to many.
Okay, okay, sir. Thank you, sir.
No, wait, let's take it again. Yes, it is many to many. But
So
here is
it depends on the quantity, sir.
Yes, it depends on the quantity. But here is where there is no relationship between you and your lecturer. There is no relationship between the lecturer and the student. I don't have any relationship with you. I have a relationship with the course, not you. There is no direct relationship between me and you. Do you understand what I'm saying?
Yes, sir.
Yes, yes, sir.
I understand the example you were giving, but that example will never happen because my relationship is not to the student, it is to the course. And the student's relationship
direct relationship. What else, sir?
that means that I have a relationship between the course and the course has a relationship with the students. So I do not, as a lecturer, have a direct relationship with the student. That is why that relationship is ternary, because it involves 3 people. Over here, we can see that it says we have a ternary relationship. That's a relationship among 3 sets. So me as a lecturer, I do not have a direct relationship between the students. My relationship is with the course. That is why if I wasn't teaching this course, you wouldn't meet me in the classroom. There is no direct communication between us. Is that clear? Now, for me to draw the diagram, I need these notations. The first shape, what shape is that?
Rectangle.
That's a rectangle.
So that is an entity. So whenever you see a rectangle, then it means you are drawing an entity. The next shape, what shape is that?
That is parallelogram.
Obisi
That's
parallelogram.
right.
Tobo, obisi parallelogram. Tobo, maya to aso. Obika parallelogram.
Parallelogram.
Chale.
Obika,
Oh, David. Ese to your book.
That's the diamond shape. It is a kite.
That's a rhombus.
The diamond
think
or kite
A
shape.
rhombus. Or
The diamond or
Charlie,
kite shape.
it's a kite. It's a kite,
Diamond
not
or-
a robot.
The diamond or kite shape is used to represent the relationship. Then
it's a
we
kite.
have the oval with an arrow on it to represent an attribute. And if it is a primary key, then you would underline the oval inside it like this, so that you know that this key here is a key attribute. So then we use N and M to denote cardinality. Okay. Then if it is a weak entity, then you have to make a rectangle within the rectangle. If it is a weak relationship, then you have to do a kite within the kite. Then if it is a multi-valued attribute, and by the way, what is a multi-valued attribute? We learned it today. Right now, what is a multi-valued attribute? Saneba.
Say once minute.
Saneba.
I say, I'm suggesting.
Where's the suggestion, Benewum?
No, sir. I joined late.
I remember up here somewhere, entity, book,
entity
about
and attribute.
address.
When we are storing,
Mhm.
when we are storing one or more values.
Good.
An attribute.
So an attribute that stores two or more values at the same
Values,
time.
yeah.
It's a composite attribute. We learned it just now that I said date and address, and date you have month, year,
Yeah.
and day, and address you
Yeah.
have street, avenue, state, region, all of those things there. So they all form part of the address. So, hey, Charlie, man, yes, we are coming here. Said the teacher didn't teach. The teacher didn't teach. Don't mind that teacher. Charlie, which in there? Oh no, yawa. Nyami wo ho mami. Nyami wo ho mami.
Yeah.
Yeah, that is a multi-valued attribute. So let's see some examples of an ER diagram. So here we have a diagram. What is this diagram showing? What we did at the top. So student, course. We have CR number, that is the course number, course title. Many-to-many relationship. Are we okay? Over here, what kind of diagram do we have here? What is this? The thing in which I'm circling, is this an entity, a relationship, or an attribute?
That's an entity.
Okay, what entity is that? What entity is this? It's course. Hey, God.
It's a course, yeah, course.
And then over here, what entity is this?
Book.
And what entity is this?
A publisher.
Okay, so this thing here is a what?
A relationship.
Very good.
And that's going to be a one-to-one relationship.
Are you sure?
Mm.
Yeah, yes, sir.
A publisher publishes only one book.
Okay. So many to many.
Many to many, because there could be many publishers coming together to
Yes, sir.
publish the book. And
Mm-hmm.
over here to the same thing. Okay. So over here we have multiple relationships. Let's see. So a student studies the course and so on and so forth. So here it shows how there are many relationships that are there. And over here we have this. So before you do a particular course, there's a prerequisite. So you must meet the minimum grade to do the prerequisite. So the many students would take the course and meet the prerequisite before they can take the next course. Here we have a relationship showing the departments and so on and so forth. So here we have the course is studied by the student. The teacher teaches the student. The teacher is assigned to a particular course. The teacher is an employee of a particular department. And we can see how the relationships are drawn from this diagram here. Over here, we have a diagram for the warehouse. So this thing here, is it an attribute or what is it?
So which entity? Which was
This one, the one I'm circling over.
the
Can you
facts?
see? Is it an
Yes, sir.
entity
That's an
or a it's an entity?
It's an entity because of the shape,
So
the rectangular shape.
this thing here, what is it?
So that's a relationship. No.
Hey! Okay.
What is that?
Yo, what is this?
Attribute.
It's an attribute. And this here is giving meaning to the relationship. So here I have the supplier supplies parts. Are we okay? So this relationship, is it one-to-one or one-to-many?
So many to many.
Many to many. Then the parts
Yeah,
go to
because
the
that's all.
warehouse. Is it one-to-one or one-to-many? Is it many to one or many to many?
Many to many.
Many to one. Sir. Many to one.
Many to one. That
Yes,
is
sir.
if the warehouse is only one. Because if the warehouse is two,
Yes,
it
sir.
would be many to many.
Yes, sir.
Yes, sir.
Do we understand? But if there's only one warehouse, then it is many to what? One. So basically, those are the type of relationships that are there. When we arrive here next week, we are going to do the practical version of this and take questions and see how we can draw them and then create relationships among them. Are we okay?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Are there any more questions before we close?
No, sir. Please, are these slides available?
They'll be made available to you.
Okay, thank you, sir.
Hello, sir.
Yes.
I want to ask this question. At what point will you know that an entity is a weak entity, or
I can't hear you. At what point will you know that what?
at what point will you know that an entity is weak? It's an weak entity.
At what point will you know that an entity is weak? Okay. So there are some entities which are weak. Weak entities normally don't have proper relationships, or they don't matter in the diagram you have. Do you understand? I think there should be an example of a weak entity somewhere in the diagrams here. Let me see. Can I get one? Good. So over here, the branch here is a weak entity. Okay, the branch here is a weak entity.
So what makes it a weekend?
Okay, so it becomes a weak entity if it is a breakaway from a main entity. So our next few lessons will be us learning about various. We haven't gotten there yet, so you don't worry. But our next lessons will be us learning something we call junction tables or junction entities. That is, it is not the main entity, but it is just there to serve as a bridge to the other entity and to provide and to help stop repeated values. So let's see if I can give you a practical example of this. Over here, if I have a diagram for a bank, right? So this is my entity called bank, okay? So I have bank here. So here I'll have the bank ID, the bank name, and over here I will have the branch, okay? Now, in here, I will have an entity in which I'm going to call branch. Now, this branch here's sole purpose is to help me, to stop me from having repeated values here. So over here, I'll have branch ID, okay? And then I will have the branch name. So it means that here, where I have branch, I'll have, let's say, branch 00006, right? Then in here, the name of this bank is, let's say, JN Bank, JN Accra or something like that. Just any fake name. But in here, I will have here being 0, let's say B01, okay? Then the name of the branch is, let's say, Kumasi branch, right? So in here, all I'll have is B01 here. So this here is weak because it really doesn't play any role apart from helping us to ensure that our table is normalized and remove dependency, partial dependencies, and also help us to do to stop repeated values. That is all that's the reason why it is here. So this could be here, whereby in here I will have branch ID and information here like this. But under the rules of designing a database, it means that my database here will not be normalized. So this table here ensures that it is normalized. Hence, this branch here is weak because it is serving another table. It doesn't have a relationship on its own, but only to the other table here. So it is weak. But anyway, as I said, when we get to those technical portions, we will see what we will do there. But that is what makes the branch weak. So
Thank you, sir.
a partial key also refers to a discriminatory attribute. A weak entity can participate further in the relationship without other entities. A weak entity can also have weak entity dependence on, it has to do with weak entities. Once we start learning about normalization, we'll learn about weak entities. So we will break off a table into two so that there are no repeated values. So one will become the main table, the other one will become a feeder table to the main table, and that feeder table becomes a weak entity. When we get there, we will explain it. But as I said, the slide goes further down to explain the ternary relationships, primary keys, what are primary keys, and show what they all are. As I said, we are going to design all of these things when we come next week. We're going to have practical questions on them. And I'm going to ask you more sophisticated questions. What are the entities that make up a hospital, a shop, a that, things like that. And then we'll draw the entity relations together. At the end of the class next week, we'll start drawing a database. And what is a database schema? What do we look out for? How do we draw the database? How do we put the relationships together? How do we create the relationships physically? Because over here, we only said there is a relationship between, for example, between the bank and the branch. There is a relationship. But when I was doing it in Excel, you can see that what I did here, the relationship is between the primary key over here and then the foreign key over here. So we will use the primary key and the foreign key to build the relationships. So that is how we'll build the relationships physically. So how will we do it in the practical sense? We will look at that when we get there. Are there any more questions?
Roger,
By
is
the way,
next week's
the
lecture?
guy, did I answer your question for you?
Oh yeah. So please, my question
Yes,
is,
Mm-hmm.
is tomorrow, is next week's class going to be face to face or online?
Is next week's class face to face or online? I thought you
Yeah,
both
I'm
said you
asking
want
that.
all. I thought you both said you want all your classes to be face to face. Oh, wait, you want all your classes to be online?
Online. Yeah, me, I did that.
Mr. Ipa,
Yes, sir. Bro,
yes,
yeah, I did that.
I agreed with Sir to do online, but then also I said on the page that we might be having some classes on face to face because of the practical sessions. You understand?
Okay.
We can't do the whole semester online. Looking at the nature of the course.
Okay, yeah.
If there's any change, we'll
Sure.
communicate on the page, and then we'll communicate with Sir also to agree on it, and then we can meet face to face in between.
So when it comes to face, bro, yeah, so I can also try and have a formal Jojo with my employer. Well, I did that with me about.
I know. We will not just put it out there without any proper communication. Okay.
So that to me, it's permission best. Why? Because I need to have the practicals. At the end, they do our findings. Why? Hello? Do you hear me?